Hello everyone, the purpose of this video is to explore dimensional analysis, or what we called it in class, the railroad track method. Using dimensional analysis, we can go from any given unit, any unit that's given to us, to a desired unit. So sometimes we want to convert from centimeters to kilometers, or from grams to kilograms, or from miles to feet, or things like that. So we can do that using dimensional analysis, and it's going to become very valuable for us to be able to do this very quickly. Okay, so I was saying that you can go from a given unit to a desired unit. In this case, we'll notify our given unit as GU and our desired unit as DU. Now, in order to convert from one to another, you must have some kind of relationship. So for example, if I want to convert from grams to kilograms, I know that 1 kilogram equals 1,000 grams. That's my relative unit. That's what's here, relative unit. So what I do is I have a given unit, and using a relative unit, I can cancel out my given unit by putting it exactly diagonal from my given unit at the beginning. So what happens is this given unit cancels out with that given unit, and then my related unit cancels out with my related unit, and in the end, I'm left with just my desired units. So let's put that into action. This is all theory, so maybe a little bit abstract, but let's put it into action so you can see what I'm talking about. So, for example, here we have the problem that asks us to convert 1.0 miles into centimeters. The first thing you want to realize is that your 1.0 miles only has 2 significant figures in it, so your answer must also have only 2 significant figures in it. So, I know that I need to get to centimeters from miles. I know I need to do that. But before I even get to centimeters, I should probably convert to meters first, because I know how to do that pretty quickly, and I know that there are 100 centimeters in 1 meter. So let's write out a schematic before we do anything else. In the schematic, I know that I'm going to be going from miles, and from miles, the only thing I can really do that I know how to do very quickly is go to feet, because I know that there are 5,280 feet in 1 mile. That's just something that you're going to have to know. From feet, I can very easily go to inches, and from inches, I can go to centimeters. So like I said, you can also go straight to meters if you want to. So if you know the conversion factors, you can go from miles to meters to feet to inches to centimeters, but that may be a little bit longer of a track. So let's see how this works out. First thing I know I need to go to feet. That's what my schematic tells me to do right here. So I said earlier that there are 5,280 feet in 1 mile. In 1 mile. So the thing you want to keep in mind here is that you want to give the bigger unit the 1. Right? So miles is much bigger than feet. So you want to give the miles the 1 and then give the feet the bigger number. So let's keep going. Now I know that I need to go from feet to inches. So I line up my feet unit diagonal from its original. So originally I have the feet right here. So now diagonally I need to put feet here so they can cancel out. So here I have feet, and I'm converting that to inches, so that goes on top. And of course feet is much bigger than inches, so I know there's 1 foot here, and there are 12 inches in 1 foot. So that takes care of that. Now I need to keep going. So I have inches down, done. Now I need to go from inches to centimeters. That's my final product. So to go to centimeters, I line it up again, and I need inches to be diagonal from each other so they can cancel out. So I'll put inches on the bottom. I'll put my desired unit on top, centimeters, and I know that in 1 inch, I have 2.54 centimeters. Okay, that is something that you just absolutely just need to know off the top of your head. 1 inch has 2.54 centimeters. If you don't know that already, that's okay, but now you know. So when I multiply all this out, I get an answer that's 160,934 centimeters. I know that that's not acceptable. So instead of that, I know I need only 2 significant figures as I indicated up here, or up in the problem. So I need to convert this to 2 sig figs, and that just leaves me with 160,000 centimeters, or 1.6 times 10 to the 5th centimeters. Those would both be appropriate answers. Okay, let's try another problem just so you kind of understand what's happening. But let me show you, when I do this, I like to cancel out my units that are diagonal from each other as I go. So for example, miles and miles are diagonal from each other. I obviously did that on purpose, but I kind of just strike through them. Let me show you again that feet and feet are diagonal from each other, so I kind of just strike through them. Inches and inches are diagonal from each other, so now I know that my unit that I'm left with at the end is in fact my desired unit. Okay, in doing another one, let's convert 1 year to seconds. Now notice that 1 year, of course, only has one significant figure, so should your answer. Let's give a schematic for what we want to do. So I know I'm starting with year, and from year, I know that how many days there are in a year, so I'll go to days. And from days, I can go to hours, because I know how many hours there are in 1 day. And from hours, I can go to minutes. And obviously from minutes, I can go to seconds. Now in this case, seconds is my desired unit. Year is my given unit. So let's set this up. I have 1 year. I know I start with that. And I know that I need to go from year to days. So think about what goes on the diagonal of year. Remember that we want to cancel it out, so you always put whatever you want to cancel on the diagonal, and then days up top. So what do you do now? Well, like I said previously, the bigger unit always gets the 1. So year is much bigger than days, so I'll give that a 1. And I know that there's 365 days in 1 year. Well, it's more like 4 1/4, but let's not worry about those nuances. So now I've taken care of days. Now I know I need to go from days to hours. So again, on the diagonal, I'll put days, and hours goes on top. And I know that days is bigger than hours, so I'll put a 1 down here. And there are 24 hours in 1 day. Keep going. Now taking care of hours. I now need to go from hours to minutes. So again, on the diagonal, we go hours, because I want hours to cancel out. Minute goes on top. And I know that hours is bigger than minutes, so 1 hour has 60 minutes in it. And then we'll keep going. Same thing, 1 minute has 60 seconds. And now I've reached my desired unit of seconds, so I know I need to stop. So let's cancel out everything to make sure it matches. So my years cancel out, my days cancel out because they're diagonal, my hours cancel out because they're diagonal, and then my minutes cancel out because they're diagonal, and I'm left with my desired unit of seconds. So I know that I did that correctly. And when I go on and do the calculation, I get something like 31,536,000 seconds. We know that's not right. We only need one significant figure, so it's actually just 30,000,000 seconds. Or in scientific notation, it's 3.0 times 10 to the 3.3 times 10 to the 7th seconds. So anyway, that's just a brief overview of dimensional analysis, and I hope you can figure out how to solve more complicated problems that require 3 or 4 or 5 or 6 steps. But it's a fun thing to try, and please do practice it with the practice worksheets that we have on Vision.